Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video I'm talking about using the discriminant when solving quadratic equations. Okay, let's start off with a little bit of work on something we previously know. This is a skill I'm going to need for you. Could you please evaluate the following where possible? The square root of 36 is going to be 6, the square root of 49 is going to be 7, the square root of 196, 14, the square root of 0, well that's 0. Now the square root of negative 36. Can you think of a number when you multiply it by itself you get negative 36? You can't, because a positive times a positive gives a positive, and a negative times a negative gives a positive. So there isn't, as far as we know, no answer for that. So we're just going to put, for now, no real solution. Now by real, real is a word that describes all the numbers we currently know on the number line. Any number, like any integer, 1, 2, 3, etc., or negative numbers, or even decimals like 0.1, or even any number we found, irrationals or anything that we've learned about in the number section, are called real numbers. And there are no real numbers that satisfy that. Similarly here, there is no real solution to the square root of negative 49, because you can't think of any numbers that multiply by themselves to get negative 49 that we know on our number line, on our real number line. Okay, we're going to need this skill. Next, we have used the quadratic formula in the past in order to solve quadratic equations. I would like you to pause the video now, and for each of these three, using the quadratic formula please, not any other method, could you use the quadratic formula to find the solutions for x in each of these cases. Pause the video and do this. This is all prior knowledge, so if you don't know, use your building blocks to go back and learn these skills. Otherwise, pause and make sure you do these questions. Okay, did you get the following answers? For the first one, the first thing I did is work out b squared subtract 4ac, which was equal to 4. Okay, and then I used that to substitute into the quadratic formula, and I got x is negative 2 and x is negative 4 as two distinct or different answers. Now in the next case, something surprising happened. B squared subtract 4ac, the discriminant, was actually 0. And so therefore it turned out that when I substituted that into the quadratic formula here, I get negative 3 and negative 3. I got the same answer both times, because when I substituted in negative b plus the square root of the discriminant, which was 0, over 2 is the same as negative b subtract 0 over 2. They give the same answer, so I got negative 3. I only got one repeated answer. Okay? Now in the other case, something even stranger happened. The discriminant in this case, b squared subtract 4ac, was negative 4. And I've just shown you on the previous slide that there's no such real number as the square root of negative 4. So at that point you can't find a number answer for it. So in here there is no answer in the quadratic formula, because this bit here, the square root of b squared subtract 4ac, that's not a real answer. So the whole thing doesn't have an answer. And that's really special. In this case, we had b squared subtract 4ac was a positive number. We got two different answers. Here we got b squared subtract 4ac was equal to 0, and we got the same repeated answer. And here we got b squared subtract 4ac was less than 0, was negative, and we got no answers. And that's true for all quadratics. If the discriminant is positive, you get two different answers. If the discriminant is 0, you get the same repeated answer. And if the discriminant is negative, you get no real answer, no real solutions. So let's formalize that idea. We know already that the solution of the quadratic formula is x is negative b plus or minus the square root of b squared subtract 4ac all over 2a. Now this thing in here, b squared subtract 4ac, we know that's called the discriminant. And we've just spotted something really special that happens with the discriminant. If b squared subtract 4ac, case 1, if that is a positive number, I'm going to get two real, distinct solutions. Real means they're numbers I'm familiar with, they're on the number line. Distinct means they are two different answers. Now in case 2, when the discriminant was actually equal to 0, okay, I got one repeated real solution. So I do get two solutions, but they're both the same number. So in the other case, I got x is negative 3, I think, and x is negative 3. Real means they're on the number line. Repeated means they're the same answer. Distinct, in the other case, it would be something like x is 2 and x is negative 3. They'd be different. And the last case, when the discriminant was less than 0, okay, it was a negative number, we got no real solutions for x. And these three scenarios you have to learn, and they're always true. Discriminant is bigger than 0, 2 real distinct solutions. Discriminant equals 0, 1 repeated real solution. Discriminant less than 0, no real solutions. So we could look at a quadratic equaling 0, we could calculate the discriminant, and we could tell before we even use the formula whether it has 2 real solutions, 1 repeated solution, or no real solutions. And that's what we're going to do. And that's how cool the discriminant is and how you can use it. Okay, let's try some questions. Now, here we're going to use the discriminant not to work out the solutions to these quadratic equations, but to see how many solutions they have. Pause the video if you feel like you can do this and answer these questions. We're asked to, by considering the discriminant, state how many solutions the quadratic equations have. So let's work out the discriminant in each case. See if it's bigger than 0, equals 0, or less than 0. Here, a is 2, b is 5, and c is equal to 2. So let's work out b squared subtract 4ac, the discriminant. That's going to equal 5 squared subtract 4 multiplied by 2 multiplied by 2. 5 squared is equal to 25, so this is 25 subtract 4 times 2 is 8 times 2 is equal to 16. So the discriminant here is 9. So b squared subtract 4ac is equal to 9. Therefore you can state b squared subtract 4ac is a positive number, it's bigger than 0. Therefore you can state two distinct real solutions. Okay, and we're done. What about the next one? Well, there's a hidden 1 here. So a is going to equal 1, b is going to equal negative 6, and c is going to equal positive 9. So let's work out b squared subtract 4ac here. B squared is going to be negative 6 all squared, subtract 4 multiplied by 1 multiplied by 9. Negative 6 multiplied by negative 6 is positive 36. 4 times 1 is 4, times 9 is 36. 36 subtract 36 is 0. So b squared subtract 4ac here is actually 0. Therefore, we know there's going to be one repeated real solution. And we're done. We haven't even had to work out any solutions. And here, there's a hidden 1 there and hidden 1 there. So what have we got ourselves? We've got ourselves that a is equal to 1, b is equal to 1, and c is equal to 3 here. So let's work out, in this case, b squared subtract 4ac. It's going to equal b squared, which is 1 squared, take away 4, multiplied by 1, multiplied by 3, which is going to be 1 subtract 12, which is negative 11. So b squared subtract 4ac is a negative number, it's less than 0. Therefore, we can state, without any extra work, there are no real solutions. And there you go, we've done that problem. And that's how you can use the discriminant to tell you how many solutions you're going to have. Right, last puzzle. This is a hard one for you now, just an extra bit of challenge. See if you can have a go at this. It says, by considering the determinant, find the value of the constant p. P is just a number we don't know, such that the following equation has equal or repeated solutions. Now here, my a is the number in front of x squared is 2, my b is the number in front of x, which is 2, and my c is just p in this case, an unknown number. Now we know if you were to have equal or repeated solutions, the discriminant b squared subtract 4ac for a repeated or equal solution must equal 0. Okay, so let's actually substitute 2 in, 2 in, and p in here. Let's say we're going to have b squared is 2 squared, subtract 4 multiplied by 2 multiplied by c, which is giving us the letter p. We know that's going to be 0. So 2 squared is 4. 4 times 2 is 8. So this is subtract 8p is equal to 0. And we could find the p that will make this true. So we could subtract 4 off both sides and we'd get ourselves the following. We'd get negative 8p is going to equal negative 4. And we divide both sides by negative 8. And we get ourselves p is therefore a half. So it turns out that it says find the value of p such that the following has equal solutions. If p was a half, then b squared subtract 4ac would be 0, so this quadratic would have equal or repeated solutions. And that's it for this video. Thanks loads for watching.